Hello everyone, welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. So in today's lesson, we are going to learn about the key features of Solidity language and smart contracts. Now let's look at some of the key features of Solidity language, but before discussing the features, let's discuss a little about the origins of Solidity language. Solidity was officially released in 2015 by the Ethereum Foundation team. So that's why Solidity is known as the language of the Ethereum, because at that time Ethereum was the only blockchain which supported building smart contracts and decentralized applications on it. And so a need was felt to have a programming language which is dedicated to building smart contracts, and that's why Solidity came into picture. Nowadays, a lot of other blockchains have also become EVM compatible. For example, we have the Binance chain, the Polkadot, Avalanche, also Polygon, which is a side chain of Ethereum and getting very popular. All of these blockchains are also EVM compatible, meaning you can use the Solidity written smart contracts and deploy those over those blockchains also. So that's a very important feature to know. Now moving on, first point, Solidity is a contract oriented language. So the meaning of this is that the main focus of writing a Solidity code is building a contract which follows certain rules and executes some actions based on those rules. So like other object oriented languages which are class based and which are used to instantiate objects of those classes, Solidity is used to build contracts. That's why it's called a contract oriented language. Second, it's a high level programming language. All these languages like C, C++, Java, even Solidity, these are all known as the high level programming languages because they are least interactive or least bothered about the hardware of the computer system. So they do not interact with they are irrespective of the machine which we are using, they would perform in a similar way because they are more closer to human languages. That's the meaning of high level programming language. Third, it's a language which is highly influenced by C++, Python and JavaScript. So when you will write Solidity code, if you know any of these languages, C++, Python, JavaScript, then you will know that a lot of things have been taken from these languages, or these languages have an influence. Though Solidity has its own unique features, but somewhere you can feel the influence of the other languages as well. Important point, Solidity is a statically typed language. What do you mean by statically typed? That you must declare the type of variables at the compilation time. So the languages like Java, C++ are all statically typed languages, but a language like JavaScript is a dynamically typed language because at the type of the variable is decided at the runtime. So, but in case of Solidity, we need to define beforehand what is the type of the variable. This is very important because we will understand the concept of transaction fee or gas fee in detail in the Solidity programs. So we need to be very, very conscious of our Solidity code so that we should not use the gas or transaction fees for that matter. So the type of variable also plays an important role there. So that's why it's a statically typed language. Also, it supports all the object oriented concepts, it supports inheritance. You can import other libraries to this, and you can also define your own user defined data types. For example, structs, enums, all these are known as the user defined data types, and you can define them in Solidity language. Solidity is a case sensitive language, and you save all your Solidity language. Basically, you save your smart contracts with the extension .sol, and the current version for Solidity is 0.8.16. So Solidity follows something known as a semantic versioning. So there is so it's divided into three parts. The version number is divided into three parts. First is the major release, second is the minor release, and third is the patch. So a lot of changes are introduced in the Solidity language very frequently. So we need to be a lot of new features keep coming, and so you as blockchain developers, you always need to keep yourself updated about the latest features which Solidity is supporting. Obviously it's backward compatible, so your code will not be affected, but it's a good practice to know what's the current features and everything. So in our course we are going to discuss about the latest version, which is 0.8.16. we are going to write all our code in the latest version. Finally, the code execution. So there are two ways by which you can write a smart contract in Solidity and execute it. One is the offline mode. So this requires installation of a few tools, like you should have Node.js in your system. You can have tools like Truffle or Hardhat would also do, and you should have a local blockchain known as Ganache. So all these tools, I mean, they are there are alternatives to these tools, but this is just an example of the set of tools required if you want to write the Solidity code offline. And in case you want to write the code online, so there is an IDE known as a Remix IDE, and here you don't have to do anything. It's just a browser based IDE where you can write your code, you can deploy your code, check the results. So it's for beginners, it's very much recommended that you should go for the Remix IDE, and that's what we are going to do for our course as well. So now let's talk about the EVM, which is the Ethereum Virtual Machine. EVM basically is the runtime environment for smart contracts in Ethereum blockchain. So it is basically a stack machine, and it is sandboxed and isolated, which means that it has no access to the network or the other resources or any file system. It's completely isolated, and it sits on the node network layer. So it is just very close to the Ethereum hardware part, very close to the hardware, and it just interacts with the smart contract. You basically deploy your smart contract on this EVM, it converts it into a bytecode, and that is basically, it just provides a runtime environment for you. Also, it's said that EVM is responsible for computing the state of the blockchain. So what exactly is state of a blockchain? So I'll give you an example. For example, in a blockchain, if you have 100 blocks till now, so that blockchain is said to be in a particular state. Now the moment another block comes, is ready to be added to this blockchain, so we would say that the state of the blockchain has changed. So EVM is responsible for computing the new state of the blockchain. Now let's discuss about smart contracts. What exactly are smart contracts? As we know that we call Solidity the language of smart contracts. So these are nothing but they are software programs which run on the Ethereum blockchain. They are the fundamental building blocks of all the Ethereum applications which exist. So smart contracts are digital agreements with automatic execution, meaning that the rules are set in a digitalized way, because you write the agreement in the form of the contract agreement in the form of a code, Solidity code, and you deploy it on the blockchain. But then there is no manual intervention required to execute it. So you can consider the example of a digital vending machine. So it's very similar to the working of a smart contract. So whenever you select a product in a vending machine, it displays you the amount needed to buy that product. If you enter the correct amount, then it verifies that you have entered the correct amount and it releases your product. Smart contracts work in the exact same way. So a predefined set of rules have already been written in the smart contract and deployed on the blockchain. Now what they are looking for is the right amount of maybe crypto or right amount of inputs, the right kind of inputs, and when they receive those inputs, they verify those inputs and then they perform the action as mentioned there. So you do not require a person to call a particular function, or a manual intervention is not required at all. Now, very important concept about smart contracts is that once deployed, smart contracts cannot be changed. This is attributed to the immutability aspect of blockchain, which we have discussed in the last lesson. And now you can appreciate how powerful the concept is. So in case once the smart contract is finalized and deployed on a blockchain, you cannot edit or alter or delete it, because that's what happens to the data on blockchain. It cannot be altered. Now that means that no one in future can tamper with the rules of that smart contract. Now while it is a very powerful concept and it has great utility for us smart contract engineers, the Solidity developers, it also comes as an added responsibility, because once we deploy a smart contract, we cannot change it. So that's why we need to write foolproof code, so that our code do not have any loopholes, and that that's why we talk about the security of smart contracts so much, because you cannot change the rules after once you have deployed it. And that's where the concept of testnet and mainnet comes. So all the Solidity code, if you run it on a professional environment, you first deploy it on a testnet which has fake ether, and you test the whole thing, and then you deploy it on the mainnet. We are going to see all of this when we are going to write the Solidity code, but for now you should understand that smart contracts once deployed cannot be changed. Also, they can be used for audits and tracking. Now, since blockchain, the data is the whole data can be tracked. It's like a public record book for you, a database book. So you can always go back in time, and you can always refer the transactions, and you can always track what's happening to your account, how much money was deducted, to whom it was sent, everything. So it's a good way of auditing and tracking. Now, smart contracts also have predictable outcomes. What this means is that given the same circumstances, smart contracts will always perform in the same way. So this is not the case in real life scenario, where we sometimes, if it's a human dependent situation, we may act differently for the same thing. But in case of smart contracts, the outcomes are pretty predictable. Again, privacy protection is very important, because in blockchain, so the whole identity of a person is based on the wallet address. It's a cryptographic address and not an exact identity. So it's kind of a pseudonymous thing, and it helps in protecting the privacy of a person. Finally, smart contracts have their utilities in a number of fields. So you can perform computations, you can create a currency of your own, you want to store data, you can do that, you can mint NFTs. We are going to discuss about NFTs in detail, but NFTs are the next cool thing right now, and NFTs can be minted through smart contracts. You can send notifications and communications to each other using these smart contracts, even in the gaming industry, like graphics. So you can generate good graphics through smart contracts. So even if in the healthcare sector, in the real estate sectors, all the sectors, they have good, in the supply chain management especially, where you need to keep a track of all the items and, in the real time scenarios, smart contracts play a very important role, and that's why it's in huge demand. So we'll conclude today's lesson by discussing about the dApps. So dApps are nothing but decentralized applications which are built on a decentralized backend or network that combines a smart contract and a front-end user interface. So in traditional Web2 applications, we have a front-end which is designed in maybe React, Next, or any other language, any other framework. So that remains the same. So front-end skills are required. But the backend changes. Here at the backend, we have a decentralized network. Basically, we have the smart contracts deployed on the blockchain for the backend logic, and the front end could be any of the Web2 front end skills. Together, they combine to form the decentralized applications. So that's it for today's lecture. I hope you liked the video. See you in the next lecture.